So the idea of separation of variables. Now, if our differential equation can be written in this form. So basically the derivative is two functions multiplied together. One of them is in terms of x, one of them is in terms of y. So because they're multiplied together, we can separate our two functions. Because I could then divide both sides by function y, move it to the left-hand side, and then rewrite it as integral of the y on function y equals the integral of function x dx. So I've separated the two completely. Now, watch out for trivial solutions. Because if function y equals 0, and it's possible that it could, but then this method wouldn't be accurate because we'd be dividing by 0. So just sort of keep an eye on that and do a quick check to see, is that a possible solution? Something like this then. So I'd have a look at this one, and we've got x squared, 1 plus y squared. Well, 1 plus y squared could never equal 0. So I know I haven't got the issue for this one. It's not going to create a trivial solution. So I'll separate them. We get dy on 1 plus y squared is integral of x squared dx. Left-hand side's inverse trig. Right-hand side's just a polynomial. So I guess that is an answer. Let's make y the subject. So y is the tan of x cubed on 3 plus a constant. Notice the plus a constant is in the tan for this though. Y dx equals x squared y. Now in this case, there is a trivial solution, y equals 0. And if you look at the actual question, because of course, if y was equal to 0, what would the derivative be? Differentiate 0, you get 0. And of course that satisfies this equation. So that's what I mean, you're checking to see whether actually is that trivial solution possible. All right, so let's find the other solution we're probably more interested in. So dy on y, integral of x squared dx. So log y, x cubed on 3. So we end up with absolute value of y is equal to some constant. Now, that constant is a positive number. Because e to the power of c, well, that exponential would always produce a positive number. So when I go here, notice I've changed my... again, the word trivial is being overused here. I've changed it from C to A, and the reason being is that, remember, C, I'm sort of saying, oh, that's a positive number, because e to the power of c has to be positive. But of course, if it's the absolute value of y equals to that, if I now write it with another constant, that constant could be negative, because we're saying the absolute value of y is equal to that. Is it that big a deal? Yeah, probably not. So we actually have two possible solutions for this one. The trivial solution of y equals 0, but also the possibility it could be ae to the power of x cubed on 3. Now we're going to find a particular solution. So let's do it via definite integrals. Okay, so I'm going to divide by cos squared y. Well, reciprocal of cos squared is sec squared. So on the left-hand side, I end up with sec squared y dy. On the right-hand side, I just have 1 over x squared. Then we match the limits up. When x is 1, y is pi on 4. That's what they're telling me. And up the top there, because we're trying to find a relationship between x and y. So integrate the sec squared, we get tan. Integrate the 1 on x squared, we get minus 1 on x. Substitute into both sides, and again I've made the y the subject for this one. We get inverse tan of 2 minus 1 on x. Now, it looks like this one is not separable, because I can't just divide by the y squared here. So, not separable? Aha! But I can do it via a substitution. Because if I look at this and think of it as not as a function of y times a function of x, but I'm looking at it as a function of y on x, I could rewrite that as a half plus a half y on x squared. Now, if I do a substitution, if I let u equal y on x, in other words, y is u times x, then the y dx I'm going to have to substitute in for, but the y dx will be u plus x du dx, using a product rule. I get u plus x du dx is a half plus a half u squared. Now I should be able to separate my variables, but my variables now are u and x instead of y and x. So playing around with all that, eventually I get that x times du dx is 1 minus u squared on 2. So separate the u's, separate the x's, and I end up with eventually. U equals 1 minus 2 on the log of x plus a constant. Let's substitute back in for u. U was y on x. Multiply by the x, and we get our final answer. So that one's a little bit more involved there, because we had to do it via a substitution in order to do it. Okay, so 13C, separation of variables.